But then as we looked to the east, it was totally clear. Saw the thing go up the whole way.
Yeah, it's rocking and rolling in New Orlando, but we were all good here.
I tell you, you got to love Florida. Appreciate them holding off those storms long enough to get this thing going. Well, now the satellite is surviving the rigors of riding a rocket into space now, but we've got a long way to go, Alec. There's a lot more to do. We've got another short burn and then a long coast phase before we have separation. And then a NOAA team will start commissioning the satellite. So as we jump ahead in the timeline, what else does that involve?
Yeah, so these satellites will be operated out of our NOAA Satellite Operations Facility in Suitland, Maryland. And over the next several months, they'll be, first of all, letting the satellite do outgassing for a period of time, and then calibration and validating and checking out the instruments. And then we'll see first light with the various instruments later this fall.
All right, looking forward to that. And we'll keep chugging along here on our broadcast. In 2021, people living in southeast Louisiana were hit with catastrophic damage from Hurricane Ida. But there was fair warning of what was coming, thanks in part to high advanced resolution imagery from GOES satellites. Here's a closer look.
Hurricane Ida will long be remembered for its destructive, deadly path that stretched from Louisiana to the northeast. For meteorologists at NOAA's National Hurricane Center in Miami, NOAA's GOES-16 satellite provided the advanced high-resolution imagery for closely tracking Ida and developing accurate forecasts from start to finish.
We did see in the GOES imagery the development of that low-level center that allowed us to go ahead and call that a tropical cyclone.
But for Hurricane Ida, it was a case of there being more than meets the eye, literally. Within the eye of Ida, GOES-16's advanced baseline imager saw 4 mesovortices. A mesovortex is a small-scale rotation in the eye wall of a tropical cyclone, and it can be a telltale sign that a storm is getting better organized and intensifying.
Yeah, when we started to notice the mesovortices in the eye, that was during a period of time when we were starting to see some pretty dramatic inner core structural changes.
And with those changes within Ida's eye, scientists saw its wind speeds go up and its central pressure drop. Both of those changes can make a hurricane's winds and storm surge more destructive and deadly. But Ida still had a surprise after it made landfall. The mesovortices in its eye continued to spin around the eye even while it was over southern Louisiana.
It's quite unusual for us to be able to see the mesovortices, say, hours after landfall. And the reason is because after a storm comes ashore, it typically loses its fuel source. It loses its the warm ocean water, and that causes the storm to weaken.
But Ida's mesovortices were still visible over land because of what scientists call the brown ocean effect. Researchers have found that some tropical cyclones can maintain their strength long after landfall, or even strengthen over land by tapping into the abundant soil moisture below it.
We think that the reason that the storm remained strong in this case was due to the presence of that marshy land. So it was almost like the hurricane didn't know it was over land. It thought it was still over the warm ocean water.
Hurricane Ida will definitely be a storm for the history books, and its full impacts are still being tallied today. For future hurricanes that threaten the U.S. and elsewhere, NOAA satellites will be our eyes in the sky to help forecasters stay on top of these monster storms.
T plus 14 minutes. Everything's good with the spacecraft and rockets so far. Let's check in now with NASA leadership. Philip Hargrove is with NASA's Sandra Connolly.
Yes, thank you, Daryl. I'm here with the Deputy Associate Administrator for NASA's Science Mission Directorate. Thank you so much for being here, Sandra.
Thank you so much for having me.
Yeah, I mean, what a day, what a moment. What was the launch experience like?
You know, absolutely fabulous. Beautiful launch. I could not be more thrilled. I have to say, I've privileged to have seen several launches. Gorgeous day, and I actually got to see those boosters land. Fabulous.
What a show. So beyond the launch itself, what's exciting about the GOES-U mission for you?
So GOES-U is so important. As you know, it's the fourth in a series of geostationary satellites that actually support our weather, whole weather forecasting system. And so they stare over the U.S. or over the actual whole Western Hemisphere and provide us really critical data as storms are forming and evolving so that we can be prepared in advance of, during, and actually support after storms occur. So it really is an important satellite system for us.
Awesome. Can you talk a little bit about this connection between NASA and NOAA and how that has developed over the years?
Yes. So we have had a partnership for 50 years with NOAA. We have been building these kind of spacecraft. We develop them, we launch them, we commission them, and then NOAA operates them. And it's to support both terrestrial and space weather. Space weather is basically the sun's sending energetic particles towards, well, it's throughout the solar system, but it's when it comes towards the Earth that it can sometimes impact our power grids and cause problems for us here on Earth. So it's important to study space weather as much as it is terrestrial weather.
Awesome. And can you tell us about what's next in this NASA-NOAA collaboration?
Yes. So again, we've had a long-term partnership, so we continue to plan for the future. So there is a GeoXO series that is going to be the GOES R series follow-on. So we're very excited to be partnering with NOAA on that. But also NASA has, on the space weather side, we have a mission called IMAP that's launching in the springtime. And we have a rideshare mission called Space Weather Follow-On, which is a NOAA mission. So we're going to be advancing our work in space weather as much as terrestrial weather.
Awesome. Very exciting stuff. Thank you so much for being here. Glad you got to witness that in person. And yeah, thank you again.
Thank you. It's fabulous.
All right. I'll send it back to you all.
Thank you. And we've been talking, of course, about GOES-U and the mission as we continue to track the rocket and spacecraft there, T plus 17 minutes, the second stage, and GOES-U making their way through space, getting ready for another burn. Alec, we want to talk a little bit about hurricanes. You were a forecaster, meteorologist in the Gulf, right? Louisiana, spent a lot of time there. Let's talk about the most deadliest and most destructive aspect of a hurricane, and that's storm surge. How can GOES-U help with storm surge? Is that possible?
Yeah, the deadliest aspect of a hurricane, definitely storm surge, the water in general, storm surge and inland flooding. And so from GOES satellites, we monitor the strength and intensity of the storm as it comes to shore. And after landfall, we have a flood mapping capability with our ABI. This is an image from our polar satellites and from the geosatellites with the ABI, and it shows the general extent of inundation after a storm. You can see this from the Louisiana coast after Hurricane Laura, and it gives emergency managers an idea of where flooding is on the ground. And using only our polar satellites, we can downscale this imagery to about 30-meter resolution. So this image that we're looking at now is from the polar satellites, and it gives you a better idea of where water is still residual in communities. And so this is residual water from storm surge and water from flooding from heavy rains.
So this is a valuable tool, as you mentioned, for emergency managers after a storm, because you got to know where your flooding is. You got to know where the people who are potentially stranded from that kind of water need help.
And to deploy resources and to coordinate response.
All right, very good. So continuing talking about hurricanes a little bit, earlier in the show we talked about NOAA's forecast for this year, and it's going to be a super active one. 4 to 7 major hurricanes with 110 plus mile per hour winds forecast for this hurricane season. Very important to the folks here in Florida and all the way up the eastern seaboard, as well as the Gulf. Why so many this year?
That's right. We're really seeing exceptionally warm sea surface temperatures across the Atlantic Basin, the Caribbean, into the Gulf, and that's the main driver. We're also seeing weaker wind shear aloft. That would be a favorable environment for these storms to take off. Right,
and so when it comes to planning, it's really important that people have a plan. I think it's probably, every year we hear it, start a plan now. Most people, I think, or many people, I should say, probably say, I'll worry about that when I hear that's a storm coming.
I think, yeah, an active season forecast is a helpful reminder to revisit your plans every year, right? It really just takes one storm to impact your community, and so it could even be a light season, and if you get hit by a hurricane, then it's a big one for you, right? We had one of our Hurricane Hunter aircraft with us at Kennedy earlier today. So with our satellite imagery from GOES, the Hurricane Hunter aircraft, we're ready at NOAA for hurricane season. So we encourage everyone along the coast to do the same.
Alex been doing a great job answering my questions and showing off the instruments of GOES, but also throughout the show, we've been asking you to submit your questions on #AskNASA from the social media. So let's take a few more questions now, if you're good with that, Alec.